Hello students. Here's assignment 3.2 where we focus a little bit more on trying to draw proper quadratic graph on graph paper and with some context to each of these questions, right? So here goes. Here's the first question. We have a student conduct an experiment to study projectile motion of a ball by throwing the ball off the top of a tall building, right? So at any instance, the horizontal distance of the ball from the building is x meters and the height above the ground is y meters. So x and y are related by the equation. We are given y equals to 28 plus 3x minus x squared. Okay, so the table is given to us, but there are two unknowns in the table, a and b. And we have already learned how to calculate a and b, right? We just substitute 3x equals to 3 into our function to get a, and substitute x equals to 6 into our function to get b. So with that, we should get a is equals to 28 and b is equals to 10. Okay, so the first step is quite straightforward. You shouldn't get this incorrect. So let's go on to the next part. So now with all the values on the tables ready, we can begin plotting the points and after that drawing the line. Okay, so after you plot the points, draw the lines, your curve should look something like this, right? This is your curve. I thicken it a little bit so that it's clearer on the screen. But of course, when you do it on the graph paper, you don't do shading like this. So you understand why I do this, okay? And you're not supposed to use red pen anyway. So yeah, you're supposed to use pencil. So you do this, got all the points. Okay, let's answer the question now. Okay, now they want us to find the gradient of the graph at x equals to 3. So previously, when we talk about gradient, right? Gradient of a straight line, okay, straightforward. We use rise over run. But gradient of a curve is a bit trickier because the gradient is always changing at different parts of the curve. That's why when they ask you to find gradient of the graph, the curve, they need to tell you exactly which part of the graph. And so they tell you, I want the gradient at the point where x is equals to 3. So what do? We draw a tangent. Now a tangent is actually a straight line that touch the curve, right, at the point where they identify, in this case, x equals to 3. So I look for x equals to 3, which is this point over here. So I use my ruler at this point over here. I draw a straight line that touches this point x equals to 3. Okay, so that's what you're supposed to do. Then after that, to find the gradient, with this tangent that we draw, okay, we just find the rise over run for this particular tangent line that we draw, and that will be the gradient that we're supposed to find. So in this case, I made an attempt here. What I get is that, oh, my rise here is actually 15 units or negative 15 units because the line is actually going downwards, and my run is 5 units. So this gives me the gradient of 3. Okay. Of course, when you draw this line, I do know that when you draw this line, sometimes some people, the gradient will be off by a little bit because we are doing it by hand and not using the computer software to do it for us. So usually we do accept a certain interval flow from negative 2.7 to something like negative 3.3. We can still accept it. Now, when you go to upper secondary and when you do additional mathematics, there is a technique for you to actually get the accurate gradient of a graph. So that technique is actually called differentiation. You have not learned that technique yet, that's why I have not actually asked you to use it. So you can just do your best in this case to find the gradient in this manner. But if you have learned how to use differentiation because you read in advance, or maybe you are a upper secondary student right now and just watching my video as a form of revision, then yeah, use differentiation to get the actual gradient. First, you can do that. Then after that, try to draw a tangent that gets as near to the actual gradient that you have calculated. You still need to present your work by drawing the tangent, right? Okay, so you do that. Okay. Right, so that is the idea of gradient and tangent. Yeah, and the next one, right? They want us to write down the height of the building. So the height of the building, since we started at the top of the building, so that position must be the height, right? So we are looking at the y-intercept here, the initial position. So the initial position, the y-intercept here is the value here is 28, right? Another way of getting this is, of course, just let x be equals to 0 and then sub it into our original function, you should get the height is 28. So there we go. Simple, straightforward question over here. Now, part 3, they ask us to find the solution to this. So what happened is originally we have y equals to 28 plus 3x minus x squared, right? So what they actually meant is replace the y with 22. That means y equals to 22 lah, right? So I draw the line y equals to 22. Makes sense to do this, right? So I draw the line y equals to 22. I saw that the intersection is over here. So at the intersection point, just use the dotted line to guide my position. I realized that the value here is about 4.4. Okay, so x is 4.4. Just use this technique. Find the intersection point, dotted line, and you should be fine. Okay. And for part 4, they ask us to determine the highest point. So the highest point is right here, right, in between x equals to 1 and x equals to 2. So it actually happens when x equals to 1.5. Okay. Now, if you do it algebraically and calculate, you actually get something like 30.25 if I'm not wrong. So if you substitute 1.5 into the original function. But of course, down here on the graph paper, the interval, each interval is 0.5. So to get actually the 30.25 is not that easy, right? So there is some allowance here. That's why you see this is approximation. There's some allowance. If you get a value that's close enough, that will be good. But what we shouldn't see is that, when x is 1 is 30, when x is 2 is 30, I should not see a flat line over here. It shouldn't be flat line. Okay, it should be a curve. So the highest point here should happen when x is 1.5. Okay, so down here I just get a close enough number, 30.5, because there are some allowance, right? And of course that's the maximum point, right? When x is 1.5, y is 30.5. So the highest point is 30.5 meters. Distance from the building when it happens is 1.5 meters away, right? Okay. So here's another question, the second question over here, right? So what happened here is now I have a ball, I throw upwards. Okay, so this kind of motion, projectile motion, throwing things. You do realize by now that most of them actually follows a quadratic function. So it's very useful, quadratic, right? A lot of application in real life when we want to calculate motion. So a ball is thrown upwards from top of building, and this time around, instead of using x and y, we use the letter h and t. Nothing wrong with doing that, right? So h represents the height, t represents the time that the ball is in flight. So the function is given as h equals to negative t squared plus 4t plus 8. Same situation. There are some unknowns in the table that you need to find. In this case, there's a p over here. So to get that, I substitute t equals to 1 into our function. We should get the value of p. So let's go. Value of p, I've calculated it to be 11. So you can see down here on the table, 11, 12, 11. So actually I know that the maximum point is going to be over here at 12, right? Okay. Now let's continue. So after plotting the points and drawing them together, my curve looks like this. It's over here, right? And of course, down here you can see the gap is quite big. So if you want to get the in-between points, you should get the in-between points, right? Having more in-between points will allow your graph to be more accurate. So you do that, and we can answer the question, right? So let's see. They want us to find the maximum height. We already know the maximum height happens when h equals to 12. And t is equals to 2, right? So that's the maximum height. We already identified it. So that's good. Just write out the answer for the tester, okay, who's asking you the questions, right? Now, next one. What are the two possible times when the basketball is at 10 meters? So the basketball at 10 meters, well, that means height is 10, right? So just draw the line h equals to 10. Then look at the intersection point. Same thing. At the intersection point, use dotted line to guide you all the way until you get the value of t. So t is 0.6 seconds or 3.4 seconds. Okay, so you do that quite easily. So important down here, I remind everybody, use dotted line to demonstrate your understanding, right, and to guide you. Okay, next, they say there's a second ball now being projected into the air, right? Fired at a high velocity maybe. Okay, and this time round the height is represented as t plus 8. So what they want us to do, they want to draw this h equals to t plus 8 on the same axis, that means on the same graph. So this is the line. Okay, it's a straight line, and I'm sure you have learned how to draw a straight line by now. Okay, you actually learned it in secondary 1. So here we go, draw this straight line, okay, and label it, right? After you draw this line, they want us to find the time where the both balls collide. That means where both the ball meet each other. That means the intersection point right here, right? So same thing at the intersection point, use dotted line to guide all the way down. You realize that, hey, the two balls are in the same position when t is equals to 3. So just write it down, 3 seconds. Okay, that's the solution. Well, I hope you're successful. We have one more practice. So this time around we throw stone, right? So we throw stone from a cliff now, and the function is given as y equals to 3 plus 7x minus x squared. So it's the same process, right? We have gone through it a few times. It's the same process. But of course, when it comes to graph drawing, the more you practice, the more comfortable you are at drawing graph. You basically can do it a little bit faster as well because you're more proficient in it. So I gave a couple more practice for you. I hope you don't mind, right? So you do this, same thing. First thing we do, we want to look for the unknown, a and b. Substitute the respective value of x into the function, and you should get the answer for a and b. So I work it out. My a is equals to 15. My b is equals to negative 0.75. Okay. So once we have that, let us move on. So same procedure, plot out all get your axis right, plot out all the axes, get the in-between points if you can, right? Once you have that, you draw a nice smooth curve, as smooth as you can, label the curve, okay, label it somewhere suitable, right here will be quite suitable, right? So here's my curve, and then after that we can answer the question, okay? So they want us to find the greatest height. So greatest height, of course, is the highest point again. So down here we have when x is 3, we have 15. When x is 4, we have 15. So we know that the highest point will occur when x is 3.5. So I read off the graph, it's about 15.2. It may not be exactly 15.2. I didn't exactly work it out algebraically, but you can, okay? But my instinct tell me it'll be here. There are some allowance, but I do recommend you actually work it out algebraically. But you don't give me like down here two decimal places or 3 decimal places, because it doesn't make sense to read to that level of accuracy on a graph paper. So that's why there's some allowance. If you are within a certain interval, it's actually acceptable. So I just used 15.2 over here, 1 notch up, right? Okay, so you do that. That's the greatest height. And then after that, they ask for the horizontal distance when it is 12 meters above the cliff. So 12 meters, same thing, draw the line y equals to 12, look for the intersection point, and use dotted line to guide the reading, and you find that the value is 1.7 or 5.3, right? Okay, so that is the value for x, okay? And then ask you to solve this, right? So this is actually the function itself. So when it's equals to 0, they are actually looking for the x-intercept. So we down here, no point, right? There's x don't have a negative, we are throwing it in only one direction. So when we look at the x-intercept, this is the x-intercept. X-intercept here which happens when x is equals to 7.4. Just read off the graph, right? Look for the x-intercept. So after that, they ask us to explain the significance of the value of y when x is 7.5. So what happened when x is 7.5? It becomes negative. So what this means is that the stone now, after throwing, is now below the cliff, right? All the way below the, so it gone all the way down already. Okay. Yeah. So I hope you are successful here. Okay. Have a nice day.